The mass of an object is actually misinterpreted in science classes like physics, because if you say this golf ball weighs something, it does. And if you say if this golf ball has a mass, it does too. Those two definitions are different. The reason why is the mass is defined as how many particles are in that object. So the number of particles. So we're going to see, for example, how many particles are in this golf ball. The weight is a little bit different. The weight is actually going to be how much of Earth's gravity is being applied on the golf ball. So, the weight is basically the Earth pulling the golf ball down to get its weight. Like, let's say you weigh 100 pounds on Earth. You would weigh different weights or different measures on different planets. Like, one time I went to a museum and weighed myself as 42 pounds. But when I went to the museum and scaled myself on a moon weight scale, or I measured if I was on the moon, I weigh only 7 pounds. If I weighed on Jupiter, I would have weighed like 170 pounds. So the weight is a little bit different than mass. If you bring yourself to another planet or another, whatever it is, with the mass is not gonna change because the number of particles that's making up the object will not change. If I bring this golf ball to the moon, the weight will change. If I bring it to Jupiter, it will change. But if I bring the golf ball to both of those objects or planets, even though the golf ball will never change its mass because it's still made up of particles. So we're going to use kilograms for mass because the metric system clearly demonstrates how much an object has in particles, or how much particles are in that object. The imperial system, like pounds and ounces, is measured in weight. So we're going to use the mass for kilograms. To add on that, when you get the answer for force, you are not going to get kilograms as the answer right away. Because we said that we wanted to see how much force is being applied on the doors in kilograms. We're going to be getting a new measure unit called newtons. Newtons can easily be calculated and easily be transferred and converted to kilograms. But newtons is basically kilograms, but in a given motion. So, the amount of newtons is going to be an object using force in motion. Because on Earth, we have 1 kilogram is going to be equal to 9.8 newtons. So, and if you put this golf ball to the top and make it fall, it's going to fall at 9.8 meters per second squared. If you drop this pen down from a top, it will fall 9.8 meters per second squared. So anything you throw off a cliff or throw off something, it will go at 9.8 meters per second squared. So with newtons, we're going to calculate how much force is being applied in motion. So anything that falls will always have a speed of this when you're falling to Earth. That is going to be relatable to the letter A in the formula, because the A is going to represent the speed of an object, or the acceleration.
This one's gonna be fun! We just whack each other with these giant ear cleaners till one of us falls off! On your mark, get set!
Sandy, are you sure we're supposed to be standing up here?
Go!
Oh.